Now moving toward the example, that how we can use the chain rule in finding the derivative of much complex function. So if there is a function and we have to find the rate of change of y with respect to x, the first thing by using the chain rule that we have to let to some variable, let's say this is equal to t, and then y becomes square root t. Now we have two functions. Here t is a function of x and here y is a function of t. Finding the rate of change of t with respect to x, this is equal to under root x is equal to x to the power 1 by 2. So we can use the power rule. Power comes down, there is a decrease in the function, and we will get 1 plus 1 by 2 x minus 1 by 2. We can also write it as 1 plus 1 by 2 x to the power 1 by 2 or under root x. So this is the rate of change of t with respect to x. Now we will find the rate of change of y with respect to t. So rate of change of y with respect to t is it is same as we did earlier. So rate of change of y with respect to t is equal to 1 by 2 square root of t. Now we will use this to find dy by dx. Now we know that by the chain rule d by dx of y is equal to dy by dt into dt by dx. So putting the values, dy by dt is 1 by 2 under root t, and dt by dx is equal to 1 plus 1 over 2 under root x. As we have to write this whole in x, so putting back the value of t in x, 2 of x plus under root x 1 plus 1 by 2 Now taking LCM, and just simplifying this, we'll get now just we can write and 2 into 4 under root x, and then x plus under root x. So this is the answer, 2 under root x plus 1 over 4 under root x plus under root x. So the function was this: y is equal to x plus square root of x whole square root of x, and we let this thing to equal to some other variable. Here we can use any other variable. I have used t, and I just found the rate of change of t with respect to x, and then rate of change of y with respect to t, and by using the chain rule just find the rate of change of y with respect to x. So this makes the whole thing much cleaner, and it just swiped the mess. So here the tip is, while using the chain rule, putting that part of the function to some of the variable, that makes the function looks complex. Here x plus under root x or x plus square root of x is equal to t, as we did in this example. So just to make that part of the function, to put that part of the function that makes the whole function very complex, just to put it to some other variable, and you will see the whole function or the whole procedure will become much easier. Let's take another example. Now if we have a function y is x to the power some power p by q, just making this function more different from the previous function x to the power n. So we have y is equal to x to the power p by q, and we have to find the rate of change of y with respect to x. Now we will use some of the methods to use chain rule and then to find the derivative by letting p by q to some other variable, or we can use some other method. So let's take this. If y is equal to x p by q, and if we multiply q on both sides to the power, then we will get y to the power q and x to the power p, and we will find the rate of change of y to the power q with respect to x, and rate of change of x to the power p with respect to x. We can use the power rule, that power comes down and there is a decrease in the function power, decrease in the function's power, and then the rate of change of this variable. So q minus 1 into the rate of change of y is equal to, here we can also use the power rule, p comes down, that power comes down, there's a decrease in the power, and then the rate of change of x with respect to x, that is 1. So we can write q and y to the power minus 1, and we can write this as y prime is p x p minus 1. So what we have to do is y minus 1 or y inverse going to the other side becomes y. So this implies that q y to the q power y prime is equal to p x p minus 1 into y. Now what we have to do next is putting the value of y that was given in the question, that y is equal to xp by q. Putting this in this equation, we will get q y to the qth power y prime is equal to px p minus 1 and x p over q. Now using the value of y to the power q is equal to x to the power p here. This is q x to the power p y prime, that is the rate of change of y with respect to x, p x p minus 1, and we can write it p by q because of the same base. Again q y prime, this will be on the other side and becomes minus p. Y prime p by q, this goes to the other side and we will get p by q minus 1. This and this will cancel out with each other, and eventually this is the rate of change of y with respect to x of this function, that x p by q, that is p by q x p by q minus 1. So x can be any complex function, or p by q be any complex value or the power. So we can use chain rule in order to find the derivative or the more complex functions, just to make our work more easy and neat, just to find what is going on in the base processing. So in the next video we will see how chain rule can be used in other type of functions to find the derivative of other type of functions in a much easier way. So stay tuned. Goodbye.